This is who PG&E is. We don't serve this area, but we serve northern Santa Barbara County all the way up the rest of the state. You can see from this number of aspects there, 15 million people we serve. The two important lines are probably the last three there, or the three important lines, the last three there. We've got over 50,000 of our customers now that have solar on their rooftops. So that's a very big issue in Northern California. And that's more than a third of all the solar connected in the US is connected on our customers. And then as a state, California has the most aggressive renewable portfolio standard. We'll talk a little bit about that. I borrowed this slide from this group at North Carolina Solar Center, and I put it up there intact always because it's such a good resource. If anybody's ever looking for information about anything, about any renewables or energy efficiency program anywhere in the country, they've got it on their website. So, but I use this just to talk about the renewable portfolio standard. And in particular, California is 33% by 2020 compared to the rest of them that are up here. Some of them are more aggressive by target, but they've got a little bit longer time to get there. So from that standpoint, it's the most aggressive up there. It's been a multi-phase process to get there. This talks basically about the RPS program in California. Renewable portfolio standards have been around since about 1991. I think Iowa had the first one. And now, as the last slide showed, there are about 29 states in the District of Columbia have standards now. California's standard first went in 2002, and the intent then was to have a 20% renewable penetration by 2017. A few years later, 2006, they changed that to 2010. We realized they'd cut 7 years out of the schedule, put in a sort of 3-year flexible compliance provision. If the projects are under contract by 2010, you had up to 3 years to get them online. So we've gone through this process now, and just a week ago, Tuesday, Governor Brown signed the 33% law. It's been something that Governor Schwarzenegger wanted. It was part of an executive order. It was part of a number of things. The bill went through 3 times, and finally in this third try, it was signed and will be enacted when this special session ends. So under California's renewable portfolio standard, there's a defined set of resources that are considered eligible. And every one of those 30 other entities up there have different rules. Most of them will have solar and wind and things like that. The hydro rules generally vary by state. In California, if a hydro plant is over 30 megawatts, it's not considered eligible to be renewable. It was just a part of not really wanting to incent more big reservoirs being built. So it doesn't really provide that much, so it's a small amount right now, and not a lot of growth potential for small hydro. But the rest of them on there, you can see a lot of activity. We'll talk a lot about wind and solar because those are the two that are really right up front in California. These are some of the other renewable programs, and I'm listing as PG&E programs, but the other utilities have similar programs. The RPS program is really the utility scale projects, but they're also customer side projects. This California Solar Initiative is the newest version of the program that resulted in the 50,000 customers with solar on their roofs. There's a hot water version of that. Self-generation incentive program actually does fuel cells and small wind turbines. And the net energy metering is also part of the California Solar Initiative. The new feed-in tariffs, and a feed-in tariff is a concept that actually originated in California back in the 80s under a different name. It was called the standard offer then. The feed-in tariff under that name became more popular due to Germany's work. They started a feed-in tariff program in 1990. But so there's a new feed-in tariff mechanism in California to try to help the smaller projects. And then the utility scale projects are looking at new mechanisms, the renewable auction mechanism. The renewables RFO is basically the device that the utilities have used for the past 9 years to get proposals in front of them for more renewables. Ours opens up next month, and it's open for a couple of months. We'll get a number of proposals in, evaluate those, shortlist those, and negotiate with those companies. The PV RFO I'll talk about, and utility owned I'll talk about later on. We've got a special program just targeting photovoltaics. The distinction on that is versus the full renewables RFO, all types of solar, all types of renewables go into that, and you end up with solar competing with geothermal and biomass and wind. And it's not always the most competitive, but under the PV RFO, it'll only compete with solar, so we'll know we'll get more solar installed that way. This is where we are right now. This is what our deliveries look like in 2010 last year. Very little solar counted. All those 50,000 customers I mentioned, that 430 megawatts, doesn't actually get attributed to the utility. It's the credits that come out of that belong to the customer, so it doesn't actually show on that pie chart. But you can see the other renewables that were out there. I think our number was around 16%. There was some two ways of calculating that because some of the contracts hadn't been approved yet. And the relevance of this is where we were at the end of last year. These are the contracts that have been signed to get us further along, to get more of them online this year, more of them online as we go towards 2020. And you can see just the tremendous amount of solar that's involved in that, and that's been a more recent phenomena that I'll talk about. So this is a breakdown of the type of contracts. You can see 2.7 gigawatts of wind, 2.1 gigawatts of solar PV, and 2.7 gigawatts of solar thermal are really the big drivers on that. Those all have lower capacity factor. Now, the last pie chart I showed was actually in energy, and this one's in capacity. The goal is in energy, so energy is a more relevant number, but people don't think about gigawatt hours as much as they think about megawatts, so people usually list it that way. The big difference is, though, something like geothermal will operate 90% of the year, so you get a lot more energy out of the same amount of capacity. Wind will operate maybe 35% of the year. Solar, 20 to 25%, depending on the type of technology. And this shows of the 109 contracts, 8.8 gigawatts that we've signed, how many of them are still active and going on. And the map is interesting because it shows the projects that are already operational and delivering into the system and those that are not yet operational. So you can see there's a lot more yellow on this map than there is green. So a lot more still to come online. Some of that's just the rate at which it's taken place. A lot of the contracting has been more recently. Some of it's also, it takes a long time to get a project online in California. That's part of what I want to talk about tonight is sort of the opportunities and challenges, and that's one of the challenges. This is where the three investor-owned utilities in California were at the end of last year, and it shows at the end of each particular calendar year since the RPS standard went in place. And overall, the estimate is that the state's at about 18%. Pretty close to the 20%, not there yet, but we've got, I mentioned, a 3-year flexible compliance, so we're assuming that we'll be in that position at our 20% target by next year. This looks at what's been going on, and I mentioned how long it takes to get one of these projects online, so you can see some of these projects it just recently started coming online. It's just taken a great amount of time to get there from contracts that were signed back in 2003 and as they've come online just slowly over the last few years. And this and the last slide and a couple others in here are ones that I borrowed from the California Public Utilities Commission. They have a obligation to report out to the legislature every quarter, and they really put out a pretty good report that if you're interested in the state of what's going on in California's renewables picture, it's a good resource to look at. This one looks at all the contracts that have been signed by the three investor-owned utilities that they regulate and maps them out according to probability or viability, and basically understanding whether or not they think they're going to come online and contribute to the overall portfolio. So you can see, the ones that are high probability, the blue ones, that the 20% is pretty much assured within the next year or two. The 33%, there's technically enough under contract for 33%, but all these projects up here have some skepticism about them, so they're not as assured of coming online. So utilities keep on signing more contracts. We all skipped last year because we had this underway, and we're waiting for the 33% law. Now that that's out, we know we can go forward with that. So what we see, though, is that there's a number of these projects that may have some challenges to come online. Now, this one's a little dated. It's from 2008, but the information is still directionally accurate. This is sort of like a whack-a-mole chart. You can push that one down, this one pops up. These are the issues that these projects will have been experiencing and they'll continue to experience. Transmission, financing, developer capabilities, permitting technology. You can see up here it's a wide range of issues that people have to get through to get a project online. And this sort of summarizes some of those issues. And there's project level issues that the individual companies delivering and creating these projects have to get through. And then there's the issues that the three utilities trying to compete to put resources online have to look at from a portfolio standpoint. And some of them are common, like transmission is an issue overall. It's kind of an irony because if you look at where the sun is the hottest in the desert or the wind blows the strongest, that's not exactly where people live. It's sort of, there's a relationship is just inverse to that. So you need to put transmission in to get these big, huge resources to where the population actually is. So transmission is a significant issue. We'll talk a little bit about permitting. Permitting's been a challenge. There was I read the Santa Barbara Independent when I got down here, and there's a good article in this issue about it isn't easy being green, and it really talks about the difficulty of trying to get a permit, especially in Santa Barbara County. But the technology also comes into play when it comes time to getting financing, and whether the developer has any experience, and the fact that a lot of these investments are based on tax credits, and after the financial meltdown, there wasn't much appetite for tax credits. A lot of the banks that were buying them went out of business. These are a few of the permitting challenges that are out there. There's something called the application for certification, AFC, that has to come out of the California Energy Commission. And the way projects get permitted is if a project is over 50 megawatts and it's thermal. Now, the original definition, they were probably thinking of a gas power plant or something, but it just said thermal. So the solar thermal projects got pulled into that same arena. And so the CEC has to issue those permits. And it's a very lengthy process to get a CEC permit, multiple years. Photovoltaic, wind, geothermal aren't under those same confines, but they still have to go through county permitting, and that's a challenge. It takes a little bit of time, especially a county that's not as experienced. That was one of the issues with Santa Barbara and San Luis Obispo and some of the counties that are just seeing their first projects now. You go over to Kern County, where they've been doing energy projects for 50 years. It's a little bit faster to get through the process. And the local issues of NIMBY concerns, and not in my backyard, it's almost, in some of these cases, like frenemies. They're friends of renewables, but they're enemies of any renewable they can actually see. So there's been that challenge that we're getting a lot of people pushing back on having renewables located where they can see them. On the environmental considerations that sort of track with some of the other permitting issues, this is just a type of list of things that we're seeing, from endangered species issues to visual impacts, noise, vibration, anything that could have an impact on anything or anybody basically ends up in that arena, and that's why it takes so much time to get through that process. This is a National Renewable Energy Lab map of where the wind potential is in the United States. California is not the windiest state. We're only the 18th windiest. We were the leader in wind production from the mid-'80s until probably about 10 years ago, and Texas took over, and Iowa's ahead of us now too, and I think Minnesota or some of the others are coming on strong too. But so our major wind resource areas are there and there. This is Tehachapi and San Gorgonio over here by Palm Springs, and then the Bay Area, the Altamont. And so you really need to get even in these cases where there's not that much wind, you need to get the wind from those areas to where the population is. And there aren't that many people living out here in Tehachapi and Kern County, so there has to be a transmission system built to take that energy delivery to where the load is. This is what's out there today. There actually are a few thousand turbines out there today, but they're the smaller ones. When these first went in the 80s, they were in the 75 kilowatt up to maybe a few hundred kilowatt range. Now they're out there and they're megawatt and a half type turbines. And interesting thing is, in addition to what's out there now, the studies have said that there's about 4,500 megawatts of new wind potential in that area. And so Southern California Edison is building a $2 billion transmission project out there to bring that wind power into the system, basically bring it into the Northern and California grid. So this is a site here of a proposed project that was going to be along this ridge line. But the challenge is that in the time that all this study of the Tehachapi area has been going on, some other things have been happening. In this case, the Department of Fish and Game started releasing California condors, highly endangered species, are now being released just 2 miles north of this site. So it makes it, condors and large wind machines don't really mix well. So this was part of this particular project. Looking at this project, it was determined that some of these units were at risk from the condor fly zone. So some of the units were taken out of the plan, but it still ended up being too risky to get approved for utility ownership at least. So that's just an example of one of the challenges that you didn't really expect going into that. And there were two solar thermal projects in the desert, and going through their environmental impact reports, there were a number of threatened species there that had to be dealt with, and how to deal with desert tortoises and finding ways to mitigate the impact that these plants would have on that. And you need to do that. You obviously can't ignore it. It's a critical species issue, but it just adds time to the process and expense to the process. And this is interesting. At the time, this is the governor's, then Governor Schwarzenegger's quote. that he assumed you could put anything in the desert because it wouldn't impact anything. That's not the way it is. The desert's a sensitive environment. So it ends up looking at whether you have public lands or private lands. There's different permitting issues on those. Disturbed lands are much easier to permit than undisturbed lands. A disturbed land being one, say, somebody's farmed for the past 50 years or dry farmed, so there's already been some impact to the environment. To put solar on there actually probably makes it better. One of the solar thermal projects has a challenge. Solar thermal takes some amount of water generally. You can do dry cooling, but it's more expensive. So they had to have a plan to come up with some water. They found acreage that was previously used for growing alfalfa. Alfalfa takes a huge amount of water to be growing in a water-short region like California, so they're putting the solar in, it will actually use less water than the alfalfa did. So it ends up meeting that criteria of keeping the water usage down and being a disturbed land, so it's not really endangering more species. So the issue is really finding a way to collaborate with the environmental community and to work on this to find a solution that can both get power plants built and protect the environment. And so it needs to be some way of getting a common ground here, coming together on that issue. And one of the issues I mentioned earlier was the transmission. There's been an effort underway in California called the Renewable Energy Transmission Initiative to try to sort of pre-identify where transmission should be put in. I mentioned this Tehachapi project that Southern California Edison's working on. When they complete it at the end of 2013, it will have been 11 years in the making. And probably 5 of those years up front, we're just getting it through the process of sort of chicken and egg. I can't put transmission in here because there's no wind resource, no wind units to take it to use the transmission, but I won't put a wind unit in because there's no transmission to take it away. So the regulators had to come together and say, okay, we think it's worth assuring Southern California Edison that you recover your investment even if nobody ever builds a wind turbine out there. So the purpose of this Renewable Energy Transmission Initiative was to identify where these transmission lines should be built going forward. Where's the best geothermal area, the best solar area, any more wind areas? So you sort of get out in front of that to shorten that process. But in so doing, they identified 11 major new transmission lines at a cost of $16 billion. And so it's going to be a substantial amount of money to get these new projects online. This is just looking at transmission. This is a typical time frame. It takes about 7 years to build a new transmission line. I mentioned the Edison project took 11 because of all the time up front on the regulatory part of it. So they're trying to cut that part of it up here, the issue identification, cut all this stuff down to try to reduce the amount of time it takes to get these new lines on. One of the things that we've been seeing, and some of it's related to what I just talked about, and I'll make the connection in a minute, but we've been seeing a lot more solar coming into proposals that the utilities receive for projects. And yellow's the solar, so you can see there wasn't much going on back here. But in the last few years, I mentioned we didn't have a solicitation last year because we had enough under contract, but we've got another batch coming up, so we expect to see a lot more solar. And so solar has been the very growth area as far as new projects coming forward. And interestingly enough, when this process first started out, when solar first started coming in greater numbers, most people were bringing in solar thermal projects, the big projects that have either the troughs or the mirrors that are used to concentrate the heat from the sun to boil water to spin a turbine. But over time, as people saw it was getting more difficult to get those types of projects permitted and built and the amount of time it took, and as the cost of photovoltaics started coming down, we started seeing a change on that, to where last year we're seeing far more photovoltaics coming in than we were solar thermal. And so now we've got a sort of a portfolio of types of solar that are out there that companies can choose from and say, I think this one fits the portfolio. In most cases, a portfolio is better off if you can blend some combination of these. But you can see the pluses and minuses on whether you're doing a thermal project or utility scale PV or distributed PV. And you can get there a lot faster with some of these big projects because they go in big chunks. But if you eat up that time in permitting, maybe you want to look at something like distributed PV where you can put multiple projects out there at 20 megawatts at a time instead of waiting years to get 200 megawatts online. You can do it even faster to get online with distributed PV. The problem is you're talking about a few kilowatts, maybe 500 kilowatts at a time, so it just takes a long time to get a lot of projects out there. The first project will come on fast, but it's just an issue of how fast you can get them out there. Then the other part of it is the smaller projects usually cost more, and I've got something I want to share on that in a minute. What we have been seeing, and I mentioned one of the reasons we're starting to see more photovoltaic projects is because that cost is coming down. This is something from 2009 that the Public Utilities Commission had a study put together for them. Most of these numbers up here in the blue bands are pretty accurate still. This combined cycle gas turbine is a typical power plant. This range is based on what the price of gas is at the time. Right now, it's probably down on this end. But when this came out in 2009, the PV prices were coming down dramatically. They've already come down more into this range now, and there's potential for them to come down even lower than that, and they'll have an impact on the type of power plant projects you see, whether they're distributed plants or central plants. And this is what's making that happen is, this is called a learning curve. And then the concept of a learning curve is when you do a new technology, each time you increase the output of that new technology, you learn something in the process. If you're doing photovoltaics, for example, and you're building a plant, and you put out so much output and you're ready for the next plant, when you build the next plant, you're going to do it better than you built the last one. So in this case, this is the crystalline silicon line that goes from 1980 down, and there's actually been pretty good comparison to the slope of that curve. That's about a 19% slope that says every time you double the output, you come down to the cost line about 19%. You get little hiccups like this once in a while where all the feed-in tariffs in Europe were drawing a lot of solar over there, and there wasn't enough supply, so it rose up. But the market will respond and build more production, and you'll see it come back down again. And so there's crystalline silicon, amorphous silicon, and cadmium telluride. Cadmium telluride, actually, First Solar is the biggest producer of that, has already hit some pretty incredible targets. They're down below $1 a watt. They're actually about 73 cents a watt, I think is their last number, compared to crystalline silicon, which is still $1.50 or something. I've got a slide on that I'll show you in a second. So one of the things that we proposed, and Edison had a variation that they proposed too, ours was to look at 1 to 20 megawatt ground mount projects using photovoltaics, because we thought it was a way that you could get away from some of these environmental issues. Instead of taking years to study a project, a smaller one in a disturbed area that had been farmed, you can get less impact in there, get it in faster, do a multiple number of those. 20 megawatts is still a sizable amount that you can put it out there and make a difference more quickly than if you're just doing a couple of kilowatts at a time. Photovoltaics, there aren't any water issues, it reduces that issue. And the intent here was also to build it close to substations, so you reduce the impact of having new transmission or the amount of time it takes for new transmission. You still need those big projects, but you need to sort of do this blended portfolio to really get there. And so this is the first one we did. It's actually a pretty small unit. It was meant to be a pilot to sort of test the concept and learn how to do this. And this was a 2 megawatt project just down the road from this major substation. So it just goes onto the 12,000 volt feeder into the substation, and it was a lot easier to get permitted and everything else. Southern California Edison has a variation on that. They're doing, I think it's 1 to 2 megawatt rooftop style, and they've just recently added some ground mounts to theirs. So the issue then becomes, what should you have in your portfolio? What's the best way to get renewables out into the market? Do you put all these big projects in, put in utility scale PV, or you just do all rooftop projects? So there needs to be really a mix of those to find the most effective way to get it out there in a reasonable time frame and still at a reasonable cost. This shows what's been going on for grid-tied photovoltaic capacity across the US. This is the Solar Energy Industries Association. But I mentioned 35% of that was in our territory, and Edison and San Diego. Between the three of us, I'm certain we're over 50% of the country. So this really follows what's been going on in California. You saw a lot of activity around residential and commercial, and just more recently, as the costs started to come down, that we've seen utilities start to get added to that. And this looks specifically just at California. Over the last years, I mentioned the California Solar Initiative. That program's been running since 2007. There was an earlier program that was running before that. So this shows what's been added statewide just over the years that this program's been in effect. And that program basically works as a rebate. And the intent is that you're trying to sort of buy down the cost of the technology. And as the cost of the technology comes down on its own due to these learning curve effects and other things, you don't need to give as much of a rebate. So the program actually had a 10-year period over it, and the amount of the rebate would step down each time you hit a certain capacity milestone. And it's been pretty successful. In fact, it's ahead of schedule. I think we're probably in the equivalent of what would have been a year 8 or year 9 capacity step downs already within the first 4 years. And this is just looking at the ones that we have on our system. I mentioned that our program, we had other ones before The CSI program started in 2007. We had some other programs that were contributing to that. And we're at that point now, 430 megawatts roughly, with the 50,000 customers. And this is where we're projecting we're going to be before the end of this 10-year program in 2016. This is a national look from GTM Research. They're part of Green Tech Media. And it looks at what's been going on the cost of solar over the past few years and a little projection forward a couple of years. And the costs have been coming down greatly. This is just looking at residential, and residential is just normally in the 2 to 5 kilowatt range. But it looks at the module, which is where the cell is. The BOS stands for balance of system, and the installation costs, the wiring, a lot of other things. And then the inverter, which is normally a part of balance of system, is called out separately here just because it does have its own separate impact and separate way to bring the price down on it. This is taken from a company. There's a combination of data points on this. There's a company called SolarBuzz that's online and tracks what's going on in the solar industry. And they do a monthly survey. And so the solid lines are from the monthly surveys they've done this month and a year ago. So you can look at how it's been progressing down. And the big issue on this is it's making progress across the board, but you're still talking about a pretty high cost for the smaller projects. And a lot of that's the economies of scale type applications in there. One of the biggest economies of scale applications is just the labor to put up one of these projects. You can take a 4-person crew, put them out in the field, putting up a couple of 2 kW installations, or you take that same 4-person crew, put them out in the field, putting up megawatts at a time. It's just a lot faster to put these up, take a lot less labor. So you see a lot cheaper cost if you get down this curve further. And this last dot down here is actually from Sacramento Municipal Utility District. Last year put out one of their own feed-in tariffs, and they put out a set price, and they said, we want 100 megawatts of bids against this set price. And it filled up in about a week, and that was at the 15-cent range. So that's at a 5 megawatt scale project. But you can compare that to where we are at the 30-cent range for a 2 kilowatt project and the 21-cent range for a 50 kilowatt project. So you can see the effect of having a scale on that. Now, one of the reasons why, in addition to that labor costs I mentioned, one of the reasons why it's expensive to do some of these smaller projects is just the individual permitting costs. I talked about the challenges that a big project has in getting a couple hundred megawatts permitted. But it's one big challenge. Once it's permitted, it's 200 megawatts permitted. With the smaller projects, they have to go through get individual building permits for every little 2 kW or 5 kW project out there. And that's what I'm calling soft costs on this versus the hard cost of the cell and the material itself, the actual capital outlay. It's like some things get lost in translation here on the lineup of the text, but you can see it there. So one of the issues is finding a way to bring these soft costs down. Germany has got their soft costs down a lot more than we have. They've been doing it for a while. They've got some other things to their credit, which is they do things more on a federally centralized basis, and the U.S. doesn't work that way. In the U.S., you look at permitting, and you'll have one national electric code, but then you'll have 50 states interpreting that and building codes in each state on electrical, structural, and fire codes. And then each of those codes will be further interpreted by the jurisdictional authorities, the cities and counties. You'll have another 18,000 authorities out there, all coming up with their own variation on these codes. And then you'll have the utilities that may have their own codes across the U.S. and what it takes to interconnect new generation facilities. So you add all these together, and it's not just on the solar. It also happens on energy efficiency and the solar thermal projects, wind, biomass. All these have to go through these county and city permitting processes. So one of the ways to get some of these costs down for the smaller projects would be to just find a way to streamline this process and get a little bit more uniformity there so people can actually get through that process much quicker. And the other thing, I mentioned the learning curve, and this is just an extraction on the learning curve, but you can see this. This is looking at what it's going to take to actually still keep getting those costs lower, because the cost of solar, while they've come down dramatically, there's still, even though I said the 15-cent one, which seemed pretty impressive, it's still about 3 times what it costs for generating that power conventionally. So Department of Energy set a new target, and they're calling the initiative Sunshot, which is supposed to be analogous to the Moonshot. And in the Sunshot initiative, they've identified a target of 50 cents a watt for a cell cost. And you can see from this typical learning curve work, we're not going to get there. We're still going to be over $1 a watt if we're just following the learning curve down at the pace that it's otherwise going. So you need doing some more innovative work to get those solar costs down even more. And this is from that Sunshot Initiative, and it shows where we are today. The $1.70 is the module, which includes the cell, is the biggest portion of the module. The balance of system and installation at $1.48, and the power electronics is mainly the inverter. So you can see we're trying to come from $3.40 a watt installed to $1 a watt installed, or from a cell module cost of $1.70 to 50 cents. And it's going to take some work to get there. And this looks at how technologies have progressed. If you look at overall the renewables that we've had out there, and California's had a long history of it from the 80s on. And so these numbers start, and most of this, they all started in 1980. And you can see how wind has come down that curve, and concentrating solar, and all these things have come down that curve. Now there is a challenge at the end of that curve. You keep coming down that learning curve, or there's just some other thing get in the way that might cause those costs to come back up again. What we've seen actually in things like wind is it made it all the way down the learning curve, but then before the recession, we had a commodity price rise. You had China and India and the developing countries buying up all the steel, aluminum, and all the other types of materials that they needed, causing those prices to go up, but those things were needed to make these turbines, so their prices started going up. So you see some of those other effects. You got the technology cost as low as you could get it, but then some other related commodities get into that. Now in photovoltaic, I added these dotted lines whether it goes up like that happened, or if it keeps coming down. And it can keep coming down if you can find some more technology breakthroughs. This chart is borrowed from Martin Green and University of New South Wales. And the type 1 technology is really the silicon technology we have out there today. It's reasonable efficiency, but pretty high cost. Type 2 is a thin film technology that's entering the market, lower efficiency, lower cost. And type 3 is really the breakthroughs that we're looking for, multi-junction, nanos, organics, other things that'll give us the ability to hit higher efficiencies and lower costs at the same time, to hit those new targets, to try to get the cost down to where it's competitive with all types of energy. NREL, National Renewable Energy Lab, does one of these every 3 years or so, just to show where the technology's been progressing. And so this is, every year it gets a little bit more complicated, but the top line, the multi-junction, the purplish, is really the sort of space-grade solar that you can get up to 40% efficiency, but it's still incredibly expensive, so you want to use it where you really need to have that small size. The conventional crystalline silicon, the blue across there, these are lab ratings, so you don't see this in the field, but they're still seeing some pretty good numbers in the low 20s on some of the better products, and high teens on some of the others on that. But you'll also see amorphous silicon and a thin film, and then you can see the new technologies being added that weren't there in the previous version of this, with dye-sensitized cells and organic cells and inorganic cells. So you can see the technologies out there. There's a lot of activity going on nationally on that, and I know there's some activity going on in Santa Barbara on that. So one thing I wanted to show here is, and this is a projection, I mentioned the PUC does a lot of this work. This is a projection from the PUC study of what's it going to take to get us to 33% renewables. And this is their base case projection. They had a number of variations on that, but the base case projection says roughly 23% of our load is going to be made up of solar and wind. And those are both very highly variable resources. And so the issue is going to be, how do you really fill in the gap and make certain that people have power whenever they need power? Now, when you look at that number, you say, well, that's fine. That's some utility commission's projection. How real is that we're actually going to have that much solar and wind out there? This is the summary of the California Independent System Operator has to have every project go through an interconnection study. And the interconnection studies, basically, if you sum them all up to the bottom number of 49,840, that's basically the peak load of the California system that the Independent System Operator operates. And so there are projects out there being proposed, and a high percentage of those are solar and wind, that actually equal the amount that's already on the system. Now, obviously, they're not all going to make it, and we've talked earlier about some of the reasons they're not going to make it. These guys have to get the sites that lined up, have to get through the permitting process, they've got to get through the interconnection and transmission process, have to have a contract with the utility, which means they have to have their price low enough. And they've got to have to get financing. So the subset that's actually going to make it through all these screens won't be that 50,000 megawatts, but it'll be some reasonable fraction of that. And that reasonable fraction will be a lot of solar and wind in that. The challenge then, if you look at this one, it's a complicated graph. The dotted black line across the top is actually a typical summer load day for a California utility. And you can see it, we peak out about 5 o'clock in the afternoon. Wind, the blue line, really doesn't get you there from trying to match the time of day that you need it. Wind's great for producing energy that you can displace other energy with, but you can't really count on it for peak uses. Solar's much closer to that. It's still not there, though you can see it's off by some. The red line is a typical flat plate solar panel. The gold line is really what happens if you put it on a tracker that you align with the sun and it comes up in the morning and you track it throughout the course of the day. Gets you more power, but also creates some other issues. You have to fill the gaps between where those power lines are and where the load is. And another issue is if you look at the gold line and how sharp that angle is going up and how sharp it is coming down compared to the load lines. The load doesn't come on that fast or go off that fast. So you have to have generation not only to fill in the gap, but also to do something with that steep ramp rate. And how do you bring some other unit down fast enough to be able to accommodate solar as it comes up that quickly? One of the other issues to look at when you're considering that is, and this is wind again, solar doesn't fit this particular issue. Sort of by definition, when it's so hot that you're hitting system peaks, there isn't any wind. And especially if you look at coastal and valley issues, the heat in the valley and the coast, if you actually get to the highest load conditions, it's going to be hot on the coast and there's no wind going towards the valley. So this is actually from 2006, and it's a week when we had a number of record days over 100 degrees across the system on a system average basis, and there were 4 new peak records set. And at the time those peak records were set, wind was putting out in the low single digits on a percent of capacity. So it's another place where you have to have something to back that up for those worst case conditions. And this looks at the other issue, which is just the variety, the variability of this and the forecastability or lack of forecastability on it. This left graph down here is from the independent system operator, and it's an infamous graph. I mentioned Green Tech Media once or twice before, but Green Tech Media had a column last year they ran that was the 10 slides that shook the world, and this was one of them. Because everybody seems to use this slide to make the same point, that sure, on average, it looks like that's not so hard to predict, except if you look at it, average never really happens. You have to try to predict all that variability. And PV solar can be the same thing. The red line in the background of that is an average day. You can predict that, and you can operate around that. But you get some cloud cover that wasn't expected, and you get the blue interactions in between. So then the challenge becomes, how do you take those and combine them onto your grid and make it so everybody can still get power when they need it? And it's going to be some combination of things. It's back to this portfolio effect that you might use energy storage, you might use conventional generation, you might use demand-side resources. We just say, you know, I could turn off this particular load at a particular time to account for the fact that the wind just dropped off. And you really want to do that in a way that doesn't inconvenience people. We have a smart air conditioner program with about 150,000 volunteers on it. And you basically cycle the air conditioner a few minutes during any hour to prevent coincident peak of everybody turning it on at the same time. And the last time we ran that program and surveyed afterwards, 93% of the people didn't even know it had been run. So if you can find a way to integrate a program like that, a demand response with storage and regular generation, you can make all these other components come together right. Now, I'm not going to go through these line by line, but just want to give you sort of a complete picture of all the things that are going on in renewable policy in California. There's a lot of activity there with a lot of agencies, both locally and federally, and there's a lot more to go. And so we're trying to do everything we can to get as much renewable on the systems, on the California system. But all these issues need to be dealt with, and you need to go through that process to get there. So it takes a little bit of time to get through that process too. So with that, I want to conclude. We think there's going to be a lot of renewable in California. It's going to continue to grow. We're going to continue to add more to that. There's been progress to date. We've got a long ways to go to get to 33% still. And we talked about the challenges that are faced along with these opportunities and the flexible resources we think we need to get there.
Can you please comment on offshore wind farms?
There's offshore wind being built in Europe right now. And it's a growing industry off the coast of Germany and Denmark and some of those places. And you've probably read about offshore wind going on the East Coast, Cape Wind, and some of those projects. The commonality between East Coast and Germany and other places in Europe is they have a pretty shallow coastline. And so they're basically taking a conventional unit, ruggedizing it for marine exposure, but they're building it off just from the seabed up. And the issue in California, we have a lot of potential. If you look at this map, blue being the superb conditions, highest level, class 7, red being the next level down, we have some blue and red conditions along the coast that far exceed what we have on shore. The challenge in California is the continental shelf drops off very quickly. So you're out just a couple miles and you're into 1,000 feet of water. And so to do it in waters like that, you really need floating platforms. There's work going on with floating platforms. In fact, there's a Department of Energy has a funding opportunity announcement that went out a couple months ago, and people are competing now to get money to do some more work on that. But the floating platforms, some of the people that have built marine floating platforms are repurposing that technology. There's also, there are a couple of Norwegian companies that have floating towers, they just float directly up and down, they're ballasted at the bottom. There's a Danish company that has a unit that's a wave converter and floating wind tower at the same time. So there's a lot of activity there, but it's still pretty expensive, and you'll have to go through the permitting process to put something out there and deal with the impact the moorings have on the environment. But we think it has a future. It's just a few years out.
On one of your slides, you mentioned that transmission is even a bigger barrier than financing. Why is that?
There are really 4 different issues to me. You have to get all those things to line up. You have to get the permitting, the transmission, the contract, and the financing to all line up. And so they're all hard to get, but the financing doesn't do you good if you don't get the transmission. The transmission doesn't do you good if you don't get the financing. So I don't think there's any one that's more important than the other. I think all 4 of those are important.
How economical would alternative energy be in California right now if there were no government incentives or programs?
It depends on the technology. I had geothermal on there, and PG&E used to own the largest geothermal field in the world at the geysers. At the time we owned it, it was about 2,000 megawatts. It's since the underground reservoir of water has since dried up a little bit, and they're using recycled water, so it's now about 750 megawatts. But at the time we built that, it was competitive with conventional fuels. Most of the other technologies without the subsidies wouldn't be there yet. The subsidies are helping bring it down. That's I mentioned with that solar program, where it's intended to reduce the amount of subsidy every so many megawatts under the assumption that they'll get their price down also. But at this point in time, most of the renewables wouldn't make it without the subsidies. But then again, you have to look across the subsidies that all forms of energy get. Some of them are a little bit less obvious, but they're all there.
How effective are underwater turbines, the current turbines that collect energy?
Well, there are multiple ways to collect energy from the ocean, and the underwater currents are one of those, and it depends on where you're located. There is a current off the California coast. It's not the strongest, the Japanese current that comes along the coast here. There are stronger currents like the Gulf Stream, and so projects like that would work. None of those are economic yet. And so you have the underwater currents, you have the wave devices, which just basically harvest the movement from the wave itself, and you have the tidal devices, which will take the effect of the moon and the tides that it creates. And those are 3 totally different ways of getting energy from the ocean. They're all in that same category, though, that they're not quite there yet from a cost-effectiveness basis.
Hal, there have been tremendous infusions of federal resources, state resources, into the clean tech energy sector. Next 5 years, where are the jobs going to be in that area?
Well, the federal money has gone into a lot of different areas. Like for example, I got a $25 million grant from DOE last year, and that's into energy storage. So there's a lot of activity in energy storage. I mentioned how we need flexible resources to make all these other renewables interact and support the grid. So energy storage is going to be one of them. I think there's going to continue to be more stuff in solar photovoltaic. There's new technologies that are coming out every day, and those new technologies are going to try to compete with the current projects that are out there. There's a lot of activity around the smart grid from an electronic control system standpoint. And I mentioned the demand response type activities. You really need the right control systems to be able to tell those loads when not to be there. You know, there's actually appliances built today that have those controls within them that just haven't been activated because the rest of the grid's not there yet. But those are some of the big areas. And of course, from a clean tech standpoint, it's not just energy production. There's also energy consumption, and electric vehicles is going to be another area. So there's been a lot of federal money that's gone into electric vehicles too. But I think those are sort of the big buckets.